Before we look into the details of how sampling and reconstruction works, let's first look at the motivation why this is actually important to us. Let's say we have an input signal x of t, which is in continuous time, and we want to filter it to receive the output signal y of t. Then we know we can do this with an analog filter, which is described by its transfer function h of s. The problem is the implementation of analog filters, for which we need to use analog circuits with resistors and capacitors. Manufacturers usually produce a set of resistors and capacitors. So if a very specific value of a resistance or capacitance has to be used, we have to combine different standard resistors or capacitors. Also keep in mind that all those resistors and capacitors have a certain tolerance, which influences, of course, their price. So to minimize costs, one is inclined to use the resistors with a higher tolerance, but then the transfer function of the true filter will most likely deviate from the transfer function of the filter that we have designed. An alternative to this might be to use digital filters, which are described by the transfer function in the z domain h of z. As an input signal, they take the dt signal x of k and produce the dt output y of k. The advantage of those discrete time filters is that they're implemented on computers, hence they're digital filters. Their precise parameter values can be easily set, and we can expect the true filter behavior to be very close to the behavior of the designed desired filter. But there exist many applications where the input signals are in continuous time, and also that the output signals or the filter signals have to be in continuous time. Yet, we still want to use digital or discrete time filters, so we need to find a way to convert a continuous time signal into a discrete time signal and the discrete time output back into a continuous time signal. Converting a continuous time signal into a discrete time signal is called sampling, and converting a discrete time signal into a continuous time signal is called reconstruction.